Above your head right now, and beneath your feet at the poles, there's enough frozen fresh water to drown every coastline on Earth. This ice doesn't just cover the North and South poles. It also traps ancient viruses, pockets of trapped gas that could supercharge global warming, and Earth's entire climate history, frozen in layer after layer, going back hundreds of thousands of years. The question isn't, is the ice melting? We already know it is, slowly, over decades. The real question we're answering today is, if all the polar ice melted in a single day, what would actually happen, minute by minute, until the world changed forever? We're not just going to guess, we're going to walk through it stage by stage. And along the way, you'll see that some of the scariest parts of this story have already started, for real, right now. Before the countdown begins, we need a sense of scale, because polar ice doesn't come close to describing what's actually sitting at the ends of our planet. Antarctica alone holds about 90% of the world's ice and roughly 70% of its fresh water. In places, the ice sheet is over 4 kilometers thick. That's taller than most mountains on Earth stacked on top of each other. If you could somehow melt only Antarctica's ice, global sea levels would rise by around 58 meters. Add Greenland's ice sheet, roughly 7 more meters. Add every mountain glacier on the planet, and you're looking at a combined total rise of nearly 70 meters. To put that in perspective, a 70-meter rise wouldn't just flood coastlines, it would completely redraw the map of the world. Florida would almost entirely disappear. Most of Bangladesh would be gone. London, Shanghai, and New York would be unrecognizable. This is the amount of water we're talking about setting loose, all at once in our hypothetical. Here's the unsettling part. Even with all of that water suddenly unlocked, the first hour would look completely ordinary. It takes time for that meltwater to physically travel from the poles into the world's oceans and mix into the global system. The change in sea level in this first hour would be far too small to see with the naked eye. Life would go on completely normally. People commuting, kids at school, fishing boats heading out at dawn, with absolutely no visible sign of the disaster already set in motion beneath the surface. Within the first day, enormous volumes of fresh water would begin pouring into the oceans. In just this first day, the sea level rise itself would only be a few centimeters, not catastrophic yet. But the real problem isn't the slow rise, it's something else entirely. The sudden influx of cold, fresh water would immediately begin disrupting seawater salinity and temperature at a scale the ocean has never experienced this fast. Marine ecosystems near the poles, already fragile, would be the first casualties. Species adapted to precise salinity and temperature ranges would have no time to adjust. But this is only a preview of a much bigger system about to break down. Here's something that makes this whole scenario feel less like science fiction and more like a preview of something real. In January 2002, scientists watched in real time as the Larsen B ice shelf, a slab of ice roughly the size of Rhode Island, thought to be stable for over 10,000 years, disintegrated in just about 5 weeks. Satellite images captured the shelf shattering into thousands of icebergs, an event so fast that researchers initially struggled to believe the data. The Larsen B collapse wasn't caused by a single event. It was the result of decades of gradual warming finally crossing a tipping point, after which the collapse itself happened almost instantly. That's the unsettling pattern climate scientists keep finding. Ice doesn't always melt slowly and predictably. Sometimes it holds steady for centuries, and then it doesn't hold at all. That's exactly the kind of tipping point behavior our hypothetical one-day scenario pushes to its most extreme, compressed version. This is where things start escalating fast. The Atlantic Meridional Overturning Circulation, or AMOC, is responsible for carrying warm water from tropical regions up to northern Europe. It's the reason countries like the UK and Iceland are far warmer than their latitude would otherwise suggest. The massive volume of cold, fresh water suddenly entering the Atlantic would begin slowing or completely halting this current within days. Fresh water is lighter than salt water, and it would prevent the natural sinking of cold, salty water that drives the entire circulation like a conveyor belt. The ironic result? Even as the world overall heats up, parts of northern Europe could experience sudden, unexpected cooling and brutally harsh winters, happening at the very same time the rest of the world suffers from rising temperatures. Some climate models suggest a full AMOC shutdown could drop regional temperatures by several degrees within just a few years, a climate whiplash effect few people are prepared for. By the end of the first month, assuming a significant portion of the melting has occurred, sea levels would have risen enough to directly threaten millions of people. Cities like Miami, Venice, Jakarta, and large parts of Bangladesh would begin to partially and permanently flood. Cairo itself, despite not sitting directly on the coast, would be affected indirectly through the flooding of the Nile Delta, one of the most vulnerable regions in the world to sea level rise due to how low-lying it already is. Millions of people in one of the most densely populated regions on Earth could be displaced within weeks. Hundreds of millions of people worldwide would be forced to leave their homes at roughly the same time, the largest mass displacement crisis in modern human history. And all of this within just the first month. Ports, airports, power plants, and financial districts, most of which were built at or near sea level for practical reasons, would all be affected simultaneously, straining global supply chains and economies already reeling from the climate chaos above. Here's a threat most people never think about. Beneath the Arctic permafrost and under shallow Arctic seas, there are massive deposits of frozen methane, a greenhouse gas more than 25 times more potent than carbon dioxide over a 100-year period. This methane has been locked away, frozen in place for thousands of years. As permafrost and undersea ice suddenly thaw in our scenario, huge quantities of this trapped methane could be released into the atmosphere in a very short window. Scientists call this a potential methane time bomb, a feedback loop where warming triggers methane release, which triggers even faster warming, which triggers more methane release. In our compressed one-day scenario, this wouldn't play out gradually. It would hit all at once, dramatically accelerating every other effect we've already described. It's one of the clearest examples of how a single change in the climate system doesn't happen in isolation. It drags a dozen other dominoes down with it. Here's where things get even stranger and far more dangerous. Polar ice, specifically the permafrost in Siberia and parts of the Arctic, doesn't just trap water and methane. It traps ancient microorganisms and viruses, some thousands of years old, kept dormant and preserved by extreme cold. Scientists have actually discovered and successfully revived some of these ancient viruses from partially thawed permafrost under controlled laboratory conditions. Fortunately, these particular viruses don't infect humans directly, but the discovery raised an unsettling question. What else might be frozen and waiting if all this ice melted at once? While the likelihood of a human pandemic emerging from melting ice remains scientifically uncertain and is an area of ongoing research, the idea itself makes something clear. Polar ice isn't just frozen water. It's a complete biological archive of Earth's history, and we genuinely don't know everything that's stored inside it. A few years into this hypothetical scenario, the map of the world as we know it would have changed radically. Entire coastlines would have vanished, millions of hectares of farmland would be submerged in salt water, and the planet's climate would be thrown into severe disarray as the ocean currents that regulate heat distribution shut down. Here's a strange twist to the story. Sunlight reflecting off polar ice, a phenomenon known as the albedo effect, had been helping cool the planet for millennia. Bright ice reflects sunlight back into space, dark ocean water absorbs it instead. With that ice suddenly gone, Earth would lose its most important natural mirror and start absorbing far more heat from the sun rather than reflecting it, sharply accelerating global warming on top of everything else that's already happened. Rising seas, collapsed currents, released methane, and a climate system in complete disarray. Here's the good news. The scenario we've walked through today, all polar ice melting in a single day, is physically impossible at this speed. Full melting, if it happened, would take thousands of years, not one day. But here's the twist. Every single step we just described Rising sea levels, slowing ocean currents, thawing permafrost, methane release, and the loss of the albedo effect is actually happening right now, just spread across decades instead of a single day. And as we saw with the Larsen B ice shelf, some of these changes don't stay slow forever. They can cross a tipping point and happen shockingly fast. This accelerated scenario isn't just a thought experiment. It's a way to understand exactly why scientists are concerned about climate change, even though it's unfolding more slowly in reality than the version we just described. If you enjoyed this video, subscribe to the channel and let me know in the comments, which climate scenario should we explore next? Let's get there together.